Number 3 and 5 on page 81, 82, huh? All right. Problem number 3. We got x is less than 3 and x is greater than 5. First off, what kind of problem is it? And or? And. How do you know? The word and is there? Okay. So, and we're looking for overlap with our problem. So if I have a 3 here and I have a 5 here, this is an open dot shading this way. This is an open dot shading this way. Friends, is there an overlap?
No.
No solution. Okay, if it was an or problem, we could do it all day long, but it's not. It's an and problem, so it's not going to work for us.
Wait, what? Wait. Why is it going those ways? Which way?
X is less than 3.
Wait, which one is that?
3.
Oh. Oh, I thought you were talking about number 1.
Nope.
Never mind.
All right. So, number 5 you said as well?
Yes.
Number 5. We have x is greater than 6 and x is less than or equal to negative 2. What kind of problem is it? And. So I have negative 2 down here. I have 6 to the right of that. So I want values that are greater than 6. And I want values that are less than or equal to negative 2. Overlap?
Never.
Never. Unless it's on a big circle and it comes and meets each other. Nope.
Wait, what about number 1?
Number 1. Number 1, you had this. So you have 3 here, you have 5 here. So open dot going this way forever. Open dot going this way forever. So this one will go from negative infinity to positive infinity because we have overlap for part of it, but it goes each way. And remember, or we only want part of it to be true, not all of it. All of it can be, yeah. 4. We did, but it's not going to hurt you to see 4. I'm not going to undo education. All right, so we have a negative 2 down here. We have a 6 here. Agree? So let's see. I have an open dot going this way. I have a solid dot going this way. It is an or problem, so it doesn't have to overlap. So this is going to negative infinity. This is going to positive infinity. So our answer is going to be negative infinity to negative 2, hard bracket at the negative 2. You want to put the word or, and then soft bracket from 6 to infinity because it's an open dot and doesn't have an equal sign. So that's the whole problem. Anything else you want to see from the homework work? 7. That's like on so the next page. All right, number 7. Number 7. X is less than 6 and x is less than or equal to negative 2. So it's an and. So I have a negative 2 here. I have a 6 here. X is less than 6 is going this way. Not yet. And here we're going to go this way. So our overlap on these problems is here. Okay, so this is pointing to negative infinity. So from negative infinity to hard bracket negative 2 is our answer. 11. Or, all right, got a 2 here, got a 6 here. It's an or problem. So I want a solid dot. This is going to be solid dot going this way forever. This is going to be an open dot going this way forever. So we have overlap, agree? But it's an or problem. So it works from here all the way. So from 2 to infinity, it works.
Also, is it possible to get no solution for an or question?
Or we'll always have some sort of solution. And will be a no solution. Yeah. 9. Okay. Number 9. Okay. -6 is here, -2 is here. Agree? It's an or. Overlap is okay. So this is going this way. It is? Oh, it's an and, so we want the overlap. All right, sorry about that. So this one, we're going to go solid dot here. So this is the region that is the overlap. Yes, -6 to -2. Soft bracket at the -6. -2 has a hard bracket. Good in the hood? 15. Why are you confused? But you're back there talking. Well, whose fault is that?
Mine.
Hopefully we'll catch you up today. But the video is still up if you want to watch it. Okay, so it's an or. It's an or problem. So we want overlap or not. It doesn't matter. All right, so this is going to be a solid dot at 5, and it shades this way forever. This is a solid dot at 7, shades this way forever. So the overlap is fine, okay, because it's an or, but an or only has to have true at one location. So this is going to be from -infinity to +infinity. Okay?
Oh, I got that.
All right. Will you go to page 83 in your books?
83?
83.
That's a big number.
That's more than I can count.
That's like almost as old as I am.
What, you're like 30?
I'm 50. All right. Here we go. So let's kind of put some definitions. We have and we have or. And has to overlap. Okay, it has to overlap. I'll clean that up a little better than that. Has to overlap. So an example would be like that is I have 2 points. If one went one way and one went the other way, the region that they overlap is here. So our answer exists in this region. Okay? So overlap has to take place. So think of an and problem as this. Let's say you have a garage that you can go in to get to your house. But the door going in from the garage into the house is also locked. So in order to get into your house, you have to open the garage and you have to unlock the door to get into the house. Okay? So it might not be the best analogy, but yeah, you're in stirrups class, so. Or only one part or both needs to be true. Okay? So if you had one that was like this would be negative to positive infinity. You could have something that did something like this as well. So that would be negative infinity to, just call it x. And then it would be y to infinity. And with an or problem, you want to write the word or in between. Or problems will always, always, always have the word or in the problem. If you get to a problem and there's not an or statement there and there's 2 inequalities and you don't see the word or anywhere, it reverts to being and. Okay? That was some rule that was made up by the really good math people at some point. All right, so now we're going to take a look at some AND problems. So if it's AND, we're looking for the overlap. So the first problem on page 83, they have something that looks like this. Agree? Okay, so the first thing you want to realize, I don't see the word or anywhere. So it has to be an AND problem. The word or is not listed. Okay, so this is an AND problem. That middle part that is highlighted is going to go with both parts of the problem. So I'm going to write this problem again, but I'm going to split it apart. Notice how the 2x plus 4 went twice. It went here and it went here. Okay? So let me just pause there. Do you feel comfortable with the work I just did? I split the AND inequality, the compound inequality, into two parts. The middle went with both of the problems. Is that okay? All good? So now all we have to do is just start solving them. So I'll subtract 4, subtract 4. Is my math okay? Divide by 2, divide by 2. Don't worry about flip. Okay, you don't have to worry about the flip on this one. Okay, and you're going to see why in a second. Is there anything up there that needs more clarification? Yeah. Okay, I haven't dealt with the 20 yet. The 20 is on the right. There's because I broke it into two problems. The 20 is on the right problem.
Okay, so how come, so you did the 2x plus 4 with 12. Why did you just do it 12?
So the middle of a compound inequality goes with both problems when you split it apart.
So you could do 2x plus 4.
So then over here, I'm going to take that 2x plus 4 and I'm going to start solving it the same way.
Oh, okay.
What was that, 16? Okay. Now, here gets tricky. Does everyone feel comfortable with what we've done? Anyone stuck? I'm going to put it back together. Okay. Now, friends, do you see how the x is on the right side on the one and on the left side of the other? Agree? So what I'm going to do is I'm going to take this and this and put them back together. Is that okay? See how I put it back together? Which on a number line, this is going to look like this. Okay, now we have to kind of look at this. We realize that this is the same thing as this. So that means I'm going to have a solid dot at the 8. And I'm going to go this way. And for this problem here, I want less than 8. Does it look like my two are overlapping? That's what we want when we have an AND. So I'm going to highlight this portion here. Okay, I can go ahead and do my interval notation. I want to go from -8. Oop, and that's a hard bracket on the -8, isn't it? Because it was a solid dot. And I'm going to go to 8. Soft bracket. So this is my interval notation. Well, I did it right here to show how it would graph. Okay. So I went from -8 solid dot, and then I went to the right. Okay. So again, friends, the and, you want the overlap to take place. If it doesn't take place, your solution will not exist. Opening the garage door with the garage door opener and using the key on the door to get into the house. I have to do both to do it. Okay, for an and. Both things have to exist. Okay, may I move to the next problem? Okay. So then I have this problem here. Oops. Boy, I can make an 8 a little nicer than that, can't I? Okay. So I don't see the word or anywhere here. Agree? Okay. So this middle part is going to go with both problems. I'm going to break it into 2 problems. Here's one problem. And here's the other problem. Do you agree? Can you see how the middle part went with both problems now? Okay. So I'll distribute 2 over the parentheses. Work the problem out. I'll subtract 18 from both sides. Divide each side by 6. What's 0 divided by 6 this week? 0. So there's one of them. So note, this is actually this. Agree? Okay, but I'm going to keep the boxed one for a reason, because I'm going to put it back together in a moment. All right. Second problem, distribute 2 over. Subtract 18. Those cancel. 6x is less than or equal to 6. Divide each side by 6. What's 6 over 6? 1. Okay. So I can put these back together. The and problem is the only one that you will put back together. The or problems, it's horribly dirty, bad math. Shame on you. Don't do math. But if this is an and problem. The people that are real smart with math, they told me what to do. All right, so I'm going to list 0 here. I'm going to list 1 here. Feel comfortable with that? So think about what this means here. I want values greater than 0. Agree? I also want solid going this way. Where does the overlap take place, friends, between what and what? Is that where the overlap takes place? Okay. So I can now write the interval notation. It's a soft bracket at the 0 and a hard bracket at the 1. Why is it a soft bracket at the 0? It's an open dot. Why is it a hard bracket at the 1? Because it's a solid dot. That's all it is. Okay? So those are and problems. And problems have to overlap. And problems can be taken apart and put back together once you solve it. Okay? May I move on? Now we're going to talk about or. Or can overlap. You're looking for where it's true for one or the other or both. Okay? So you know you're working an or problem on this first one because something should be very, very obvious. Yeah, the word or is there in the problem. That's sitting right there. Okay? So we're going to solve each. Divide by 2. Do you feel comfortable with my math? Second problem, distribute 3. Subtract 18. Those cancel. 78 minus 18, I believe, is 60. Okay, what kind of problem was this? What kind of problem was it? Or. So we're looking for overlap, but we don't have to have overlap. So I have an 8 here. I have a 10 here. Agree? So let's do this one. I want values that are less than or equal to, so I'm going to go this way. So that's going to negative infinity. Agree? And then on this one, open dot going this way. So I do not have overlap, correct? But overlap has to take place with and. Overlap doesn't take place with or. So you're going to write negative infinity to 8, hard or soft bracket on 8. Hard. You're going to write the word or, soft bracket on 10 because it's an open dot. And this is our interval notation solution. A little bit different to think about. Agree? So I'm going to pause there. And the assignment I'm going to give you, it's on page 85, 86. And I would like you to do 10 through 17. But here's the disclaimer. Due at end of period Friday, which is tomorrow. Yeah, so I would say get a start on it, but I bet you what I have planned for tomorrow would allow us to make sure we are completely done with it by the end of class. So if you're here, you get the points for it. If you're not here, you need to do it on your own. I guess you can watch the video. Okay, does that make sense? Friends, this is going to be different. So if you get to a point where you're a little bit stuck, know that the odd answers, so 11, 13, 15, and 17 are on the video. Okay, the video probably has 1, 3, 5, 7, and 9 in there. But I only want us to focus on 10 through 17. If you're getting stuck on it, you can pull up the video in the red folder, and this will be titled SLI 7. Okay. Good. Hey, you guys want to do what? Yeah, but you don't have to do number 1. 10 through 17. But yes, that one's correct. Yep. Hey, do you guys want my riddle? You want a riddle? All right, here comes a riddle. You tell me how it works. Ready? Okay. Myself and 2 of my friends. So how many people am I talking about now? 3. So there's 3 of us that took a road trip. You still with me? And we're heading east. So we're going to stop in some little Midwestern town for the night. So we find a hotel that's pretty inexpensive, has 0 stars because it's really bad, but it's inexpensive. So we walk in, me and my 2 friends, so there's 3 of us total. We walk in. The hotel clerk says hello, I was like, hey, can we have a room with 3 beds? And they said, sure, because, that always exists. So the hotel clerk says it'll be $30 for the room. There's no tax. And so the 3 of us decide, okay, we'll each give $10 each for the room because 10 times 3 is 30. Agree? So we all get up to the room. We're fighting over the who gets what bed. And, we were too noisy. So we go open up the door, and there's the clerk. And the clerk is holding 5 $1 bills. And said, I made a mistake. Today is Thursday. The room's only $25. And so we decide, you know what? Give us each back $1, and you keep the $2 tip. Okay, so originally we went 10, 10, 10 for the room. We each got $1 back, which is now $9.99. 9 times 3 is 27. I just gave a $2 tip to the clerk, which is $29. Where did that extra dollar go?